Good day, everyone. So hope you had a wonderful weekend. We are back with ITU's webinar series on digital transformation for cities and communities. So we are very pleased to welcome you all to episode 6 on smart city platforms. So this episode is brought to you by International Telecommunication Union, China Information Communication Technologies Group, Electronics and Telecommunications Research Institute, and the Spanish Association for Standardization. So before anything else, so we would like to invite you all to drop a quick message and state your name and the country from which you are connecting from. So before anything else, we will, I think I see like someone from Vienna, so welcome. So without further delay, I would like to give the floor to Dr. Bilal Jamusi, Chief of the Study Groups Department of the Standardization Bureau at the ITU, to give us his opening remarks.
Good morning, ladies and gentlemen. It is my pleasure to welcome you to episode 6 of the ITU webinar series on digital transformation for cities and communities. Today's webinar is dedicated to the theme Smart City Platforms, and it is jointly co-organized with China Information and Communication Technologies Group, CICT, Electronics and Telecommunications Research Institute, ETRI, and Spanish Association for Standardization, UNI. For years, ITU has worked to support the development of smart sustainable cities and coordinate the deployment of ICTs and digital technologies through standardization. Smart city platforms are crucial for integrating digital platforms, data interfaces, and other third-party systems. They are the key component that enables the exchange of information between different vertical platforms, allows cities to scale up digital solutions and IoT services, and improve the overall performance of smart sustainable cities. However, based on our experiences working with cities, we know that many smart city platforms are developed independently. As a result, these platforms often do not have the same functions and are unable to exchange and share data collected by the data sensors or even between platforms. This lack of interoperability has severely limited the effectiveness of many IoT-based applications and services. With more cities striving to use smart technologies to achieve sustainability and reach ambitious global targets, such as Sustainable Development Goals, we need to ensure that the interoperability requirements of smart city platforms are properly met and that they are also developed with scalability, security, and performance in mind. ITUT Study Group 20 is the lead study group on the Internet of Things and smart cities and communities. The group has developed technical standards that help build interoperability into smart city platforms and systems. For example, recommendation ITUT Y.4200 defines the interoperability requirements of smart city platforms, helping to ensure the correct functioning of city services. Meanwhile, recommendation ITUT Y.4201 defines the high-level requirements and reference framework of smart city platforms. These high-level requirements include a comprehensive and updated repository of city information, infrastructure lifecycle management, inter-system communication, security support, and more. I'm very excited that today we will be learning more about these standards. I also want to take this opportunity to quickly highlight the United for Smart Sustainable Cities Initiative, or simply U4SSC. U4SSC is a UN initiative coordinated by ITU, UNECE, and UN Habitat, and supported by other 13 United Nations agencies and programs to achieve the Sustainable Development Goals. U4SSC is working on a deliverable that highlights the importance of smart city platforms in addressing global challenges. The work of U4SSC is open to all interested stakeholders, and I want to encourage you to have a look at the work of U4SSC and consider joining this great initiative. We have a busy schedule ahead. Without further delay, I will pass the floor to our moderator. Thank you for joining us here today, and I wish you all a very productive and informative webinar. Thank you very much.
Thank you, Dr. Jamusi. So I do see participants connected from all over the world. So we have experts from India, Uganda, Lebanon, Rwanda, even Saudi Arabia. So welcome to all our participants. So before we delve into the heart of today's discussion, please take note of how the session will run. So my colleague is projecting the slide. So first thing is that the recording of this episode and all the presentations will be made available on the event webpage. So if you have any questions to our participants, please do use the Q&A icon seen at the bottom of your screens. And of course, this closed captioning is also available for this event. You may turn it on by enabling the closed captioning icon. So we would also like to take this opportunity to thank Mr. Junsub Lee for his hard work and also the efforts to put this program together. So we have an excellent list of panelists for today's discussion. And I would now like to call on Dr. Hyung-Jung Kim, Working Party 1 co-chairman of the ITUT Study Group 20, to lead us through the session. So Dr. Kim, the floor is yours.
Okay, hello, Chara. I believe everybody can hear my voice quite clearly.
Yes, Dr. Kim.
Yes, yeah. Can you see my face? Okay.
Yes, we can see.
Okay, thank you, Chara, and thank you, Bilal, for this kind introduction. My name is Hyung-Jun Kim. I'm the co-chair of Working Party 1 of ITUT Study Group 20. It's my great pleasure to be your moderator for this webinar. In this session, we will be looking at the latest standardization activities for smart city platforms that are being carried by ITUT Study Group 20. So as we will demonstrate today, these standards will provide valuable guidance for smart sustainable city worldwide to achieve interoperability in smart city platform. If we have a sufficient time, we will also have a question and answer section toward the end. We have lots of information to cover today, so without further delay, please welcome our first speaker and my colleague, Junsub Lee. He is a rapporteur of ITUT Study Group 20, question 1. The Junsub Lee, he joined to the ETRI in the year 1999, and he is the director of Intelligence Convergence Research Lab. Currently, he is a rapporteur of question 1 of ITUT Study Group 20, which is covering interoperability and interworking of IoT and smart city and community applications and services. Also, he is an editor of the IoT and SCNC standard roadmap maintained by JCA, IoT, and SCNC. So please welcome him with applause. The Junsub, the floor is yours.
Thank you, Dr. Kim. Please wait a few seconds to share my screen. I'm not sure. Can you see my slide?
Yes, I can see your slide quite well. Please go ahead.
Yeah. Yeah. Okay. Thank you, Dr. Kim again, and hello everyone. My name is Jun-Sub Lee, as introduced by Dr. Kim. I am the rapporteur of the question 1 in study group 20. So as a question 1 rapporteur in study group 20, I will briefly introduce the activities of question 1 study group 20 on smart city platform. So after my presentation, I believe that a more detailed presentation on smart city platforms will be given by the editors of relevant draft recommendations or published recommendations. So this is the overview of question 1 in study group 20. The title of question is Interoperability and Interworking of IoT and Smart City and Community Applications and Services. So this means that question 1 is responsible for the standardization of interoperability and interworking of IoT and smart city applications. For this, question 1 is dealing with the use cases, requirements, and architectures and data set and format to support interworking and provide interoperabilities between the IoT and smart city application and services. So this includes not only within a silo, but also between the various silos in the cities and communities. So related to sustainable development goal is 11, which is sustainable cities and communities. And published recommendation under its responsibilities are listed here. So Y.4100, which defining common requirements of the Internet of Things, and Y.4111, semantics-based requirements and frameworks for the IoT. 4113, requirements of the network for the Internet of Things. And 4114 is specific requirement capabilities of Internet of Things for big data. And 4200 and 4201 is about smart city platform. The 4200 is requirement of interoperability of smart city platform, and the 4201 is high-level requirement and reference framework for the smart city platform. Also, Y.441 is functional framework and capabilities of IoT. 4461 is a framework of open data in the smart city. And Y.4552 is the application support model of Internet of Things. Among these published recommendations, as I already mentioned, Y.4200 and Y.4201 are smart city platform related recommendations, and this will be reviewed in detail by Mr. Jishin Sang after my presentation. And also in question 1, there are 6 ongoing items: Y.DT interop, Y.infra, Y.IoT SD ARC, Y.ISMS, Y.NMM ISMS, and lastly, Y.DTF requirements. Among these, Y.IoT SD ARC, which defines the frameworks of service interworking with device discovery and management in heterogeneous Internet of Things environment, was consented at the last study 20 meeting in the last month, and it will be Y.4477 after the consultation. Also, there are a couple of items for digital twins. So Y.TT interop will define interoperability framework of digital twin systems, and Y.TTF requirements will define digital twin federation, which about how digital twin systems will collaborate each other to solve complex problems in a city. So among these ongoing work items, Y.infra, Y.ISMS, and Y.NMM ISMS are related to smart city platform. Also, these 3 ongoing works will be introduced by the editors after my presentations. So these are list of recommendations published or under development, which are related to smart city platform. So Y.421 defines high-level requirements and reference framework of smart city platform. And Y.4200 defines the interoperability requirements of smart city platform. Ongoing draft recommendations, Y.infra is defining the requirements of sensing and data collection system for smart city infrastructures. Y.isms is defining the functional framework and requirement for disaster monitoring system. And Y.nmmisms will define metadata model for the disaster monitoring system, which is defined in Y.isms. Okay, and this slide shows the relation and position of previous 2 recommendations and 3 ongoing draft recommendations, which are related to smart city platforms. So firstly, Y.421, it covers green part in here. So it defines reference frameworks, which include service and application providers, sensing and infrastructure providers, and data and computation providers. So it also defines the functions of smart city platform itself. So all green part is covered by Y.421. And Y.4200 define the interoperability requirement of the smart city platform, shown in blue here. So it's defining the 3 interfaces in blue: service interface, acquisition interface, and interoperability interface. So those 3 interfaces are covered by Y.4200. And the ongoing draft recommendation, Y.infra, is positioned just above the city infrastructures. So Y.infra describe essential infrastructure of city and define the requirements of the system for sensing and data collecting from those infrastructures. That shows in purple. So also it extends the acquisition interfaces defined in Y.4200 as shown in purple. So there you can see the 2 arrows, vertical arrow on the right-hand side. So which is go directly from smart city platform to the sensing and data collection system. And the other one is go directly to sensor itself. So this Y.infra is extending the acquisition interface defined in Y.421. And Y.isms is in between smart city platform and the sensing and data collection system, which is defined in Y.infra. So it's shown in pink here. Also, Y.nmmisms is related to Y.isms. So that's the disaster monitoring system, which utilize the functionality of Y.infra, also deliver some function to smart city platform defined in Y.421. So all these items will be introduced by remaining speakers. So Y.421 and Y.4200 will be introduced by Mr. Jixing Sang, our working party co-chairs. And the Y.infra and Y.isms and Y.nmmisms will be introduced by the each editors of those draft recommendations. And I think it's all for my presentation. Thank you for your attention, and back to you, Dr. Kim.
Okay, thank you so much, Jun-sup, for your kind presentation. My intention is that after getting all the speakers' presentation, while we are having the remaining time, we'll have the Q&A session. So beforehand, please feel free to pose your question to each of the speaker using the Q&A icon seen at the bottom. Okay, so I would like to invite the second speaker to this the session, Dr. Jixing Sang, the Technical Director of the China Information Communication Technology Group. And he is also the Working Party 2 of Study Group 20, co-chair and vice chair, ITUT Study Group 20. And Mr. Jishin Sang, he joined the Wuhan Research Institute of Post and Telecommunication in 1998 after obtaining his PhD degree in a pattern recognition and intelligence system from Haozhong University of Science and Technology, China. He had a division of innovative research on smart city in the state key laboratory of optical communication technologies and networks since 2010. He has been active in standardization bodies such as ITUT Study Group 17, Study Group 13, Study Group 5, and Study Group 20, CCSA, TC8, and TC10. So please welcome him with big applause. Dr. Jishin Sang, the floor is yours.
Thank you, Dr. Kim, for your introduction, and also thank Mr. Junsab Lee, our question one rapporteur. So I need a little time to open the document. Can you see my screen?
Yes, Dr. Jishin Sang, yes, I can see your screen.
Okay. So I will give an introduction of this series of ITUT standards on smart city platform. I'm one of the editor for this recommendation. And as Mr. Lee have just introduced that we have started the smart city platform recommendations in question one. And previously, ITUT started the standardization work and also the pre-standardization activities in the focus group on smart central city. And it started at 2013 and concluded the work in 2015. And so I reviewed the standardization roadmap for smart cities, and you can say that generally we would like to categorize the standards of smart city in several parts. The first part is smart city management and assessment standards. The second part is smart city service standards. And in the middle, we have the category of ICT standards. We think ICT is very important for smart city standards. And in the bottom, we have the buildings and physical infrastructure standards. So that is our roadmap developed in the focus group in 2015. And in 2015, we started the study group SG20 that is focused on IoT and smart city. So in SG20, we have the work item on smart platform. As Dr. Lee have just introduced, smart city platform is very important for ICT hub for smart city. And you can see this diagram that is from the communication view. That is multi-tail of smart central city ICT architecture. We emphasize the physical from a physical perspective. And you can also find the picture and the diagram and also the related technical report from ITU website from the page of ITU focus group on smart sustainable city. And that is the diagram of Y.4201 high-level requirements and framework, reference framework of smart city platform. And the left part is a diagram high level, and you can see that SCP, smart city platform, is at the core of the ICT part of smart cities, and it have interface connected with service and application providers, and it also have interface connected with sensing and infrastructure provider. And from the eastbound, it have interoperability interface connected with data and computation provider. And in the right side is detailed blocks, functions of all the parts. In SCP, we have a detailed functionality description of security and management function, and of service supporting functions, and for interfacing functions, for the data knowledge functions. We also have acquisition, interconnection functions. So that is the diagram of SCP. And so generally, the recommendation of Y.4201 is to explain the functions in text. And that is the diagram of Y.4200. That is requirements for the interoperability of smart city platform. And the left side diagram is the evaluation of how the verticals to integrated into a smart city platform. You can say we have several, maybe in a city we have several vertical systems, and then generally, gradually, it combined, it merged to the smart city platform. And in the right side, we have a diagram. So you can see that this recommendation Y.4200 is to define the three interfaces of the smart city. That is the service interface, interoperability service interface, and acquisition interface. So that is the main idea in this recommendation. And for the series of standards on the smart city platform and the relevant draft standards, and you can say currently we have 2 recommendations published, and we also have some ongoing work items. The first one is Y.infra, and just as Dr. Lee have shown that it have connection with the Y.4201, and also have Y.isms. That is ongoing work item, and we also have just published, just concerned Y.4213. That is IoT requirements and capability framework for monitoring physical city assets. So this work item is also related to this series of recommendations. And we also have a new created work item, that is Y.emm request. It's requirements for real-time event monitoring and integrated management in smart city platform. And the last 2 work item is carried out is developed in Quasi 2 of SE20. And so we can say that several ongoing work items is developed. Generally, it was developed in the bottom part of the infrastructure and sensing systems. We have the use case of these two recommendations, and so we are very happy that there are applications of the I2T recommendation. And then the first case is the sharing application platform for government information system that is conducted in Hubei province of China. And that platform is there in accordance to the Y.4201. And through the platform, many isolated data islands have been eliminated. At present, there are more than 700 digital government applications from over 17 government departments running on this platform. And several other provinces in China are already adopting a similar structure as described in the two recommendations. So that is the case in China. We also have a case in Spain, and that is in a city of Benidorm. That is a smart destination platform for tourism. And the smart city platform is an open platform that is able to receive information from a wide range of external communication system sources, including TripAdvisor and Twitter, Airbnb, and so on. And the smart destination platform has made a remarkable improvement to the tourism industry in the city of Spain. And currently, there are more than 24 other tourist destinations have implemented this type of smart city platform in Spain. So you can say that the two recommendations had immediate implicated in some countries. And so that is my introduction of these two recommendations and the relevant ongoing work items. Thank you for your attention. Thank you.
Okay, thank you so much, Dr. Zhishen Zhang, for your kind presentation. Originally, I imagined that your presentation will be about the 30 to 40 minutes, but your presentation are quite short. It's okay. Anyway, let's take a look at let's handle our remaining the time with Q&A. Okay, with that, may I kindly invite our third speaker to this session, Dr. Yuguang Chang, the Senior Director, the Bible Home Telecommunication Technology Limited. And Dr. Yuguang Chang, he's currently the Senior Director at Bible Home Telecommunication Technology Co. Limited, China Information Communication Technology Group. He has worked for CICT for more than 10 years. He is editor of several recommendations and ongoing work item in I2T. He is concentrating on domain including smart city, Internet of Things, fiber access network, etc. So currently he is actively working for standardization in I2T, IEEE, BBF, ETRI, CCSA, and so on. So please welcome him, and Mr. Dr. Chang, the floor is yours. Please.
Thank you, Dr. Kim. Thank you for having me here. Let me share the screen. Can you see my screen?
Yes, I can see your screen. Dr. Chang, please go ahead.
Okay, perfect. Today, I will bring introduction for the ongoing work item in question 1, ITUT study group 20, which is the Y.infra, the requirements of sensing and data collection system for city infrastructure. Excuse me. So in this presentation, firstly, we're gonna introduce some basic
Dr. Chang,
structure. Yeah.
excuse me, sorry about that. We cannot see your screen.
Cannot see my screen. Let me share again. Can see my screen now?
Yes, we can see your screen. And then if you could just put it in the slideshow mode.
Is it okay now?
Yes, we can see it. Thank you.
Yes, perfect. Thank you.
Okay, thank you. So in this presentation, firstly, we're gonna introduce some basic city infrastructure for a smart city. Then we're gonna explain the definition of sensing and the data collection system and the relation between the wider infra and other recommendations. Let's say mainly the Y.4200 and Y.4201. And also we are gonna present the functionalities of sensing and data collection systems. Let's first take a look at the basic infrastructures for smart city. As we know that smart city is aiming to promote the intelligent urban planning, constructions or management and other kind of services in the city by using ICT, which is information communication technologies, such as IoT, Internet of Things, or cloud computing, big data, and so on. So the city infrastructure is actually the fundamental element of the smart city. So in Y.infra, we firstly define some basic city infrastructure of as a smart and sustainable city. And also point out the improvement we can do for those city infrastructure through ICT. There are 8 basic city infrastructures defined in Y.infra. And I think, of course, we are not intend to list all the city infrastructures because cities from different region or different countries may have quite different deployment of infrastructures. So here we just list 8 basic ones. First, we have the energy infrastructures. These are the facilities such as gas, heat, or the electric supply that are the energy infrastructures which to build to meet the needs of manufacturing or productions or for human living environment in the smart city. And these facilities need to be operated safely, which can be monitored through ICT. For example, we can put sensors to those infrastructures, and sensing data such as fire detection can be collected. And this kind of information is quite important for the smart city platform. Then we have the water supply and drainage infrastructure. The water supply infrastructure refers to the facilities for the water collection, processing or water transmission, and water distribution. And the drainage infrastructure is the facilities for sewage or rainwater collection, even regeneration or that kind of thing. Like the energy infrastructures, they are also basic infrastructures to meet the need of productions or the human living environment, and also can be monitored through ICT. The sensing data such as water saving or city flood control or irrigation, that kind of data can be collected by the sensors if we deploy the sensors to those infrastructures. And the third one is the transportation infrastructure, which include road transportation, railway or water transportation, or the air transportation. They also can be monitored by ICT. The sensing data such as the road traffic control can be collected by sensors. And also apart from that, they can even be improved by ICT. Like ICT can be used to promote energy saving and or the new energy transportation equipment, or improve the transportation management system to make it more intelligent, which are using AI, artificial intelligence. And then we have the post and communication infrastructure. This kind of infrastructure is like the facilities of the urban post to provide the universal post service in a smart city or in a country, and also the telecommunication network, both mobile and fixed network. And this kind of infrastructure support the information society of a smart city. Specifically, the telecommunication network itself is ICT facilities. So the sensing data such as post mail trailing information like this, the data is like this, it can be tracked and collected for the road information for the smart city platform. Okay, so we also have the disaster prevention infrastructure. Those infrastructure are deployed to implement early warning and prediction for disaster in order to reduce loss or casualties, to have a unified emergency response in order to coordinate the emergency rescue work in the disasters like fire or flood, earthquake. So ICT can be used to support, for example, large-scale surveillance network coverage for like the forest area or the river, etc. And sensing data such as the weather forecast in the forest or the water level in the river can be collected. through the system. And then is the cultural, sports, and educational infrastructure. Those facilities will include like kindergarten, schools, or museums, galleries, or other facilities. And ICT technologies also can use to improve the utilization rate of these facilities. For example, if we put surveillance cameras in the museum, we can monitor the visitors' float rate in real time. We can also deploy a smart education system in school to improve efficiency. Well, actually, right now we have an ongoing work item in Q3, study group 20, to define the smart education system. And the seventh one is the health infrastructure, which include hospital, health center, disease control agency, or other kind of facilities. And also ICT could be used to improve the processing medical emergency events such as the epidemic or disease control, food poisoning, and also carry out resource scheduling, medical rescue, or epidemic prevention. And medical information system can be deployed or used to share the medical resource such as hospital beds, or the medical information, or the drug management, especially the electronic health records. And ICT also can support telemedicine diagnosis, including collection of the medical parameters and online expert consultation. I think all of this is quite important services to be provided in a smart city. Last but not least is the social welfare infrastructure. Social welfare infrastructures will include kind of a welfare home, or the like homeless treatment center. And also ICT can use to maintain the information of all kind of these welfare facilities and institutions to guarantee the service ability to rescue the homeless people or the disabled people. So then let's take a look at the definition of sensing and data collection system. In this figure, as we have seen from our previously speakers' presentation, is a figure from Vital 4201. The sensing and data collection system belongs to the sensing and infrastructure provider part in the bottom. We can see from this figure that the city infrastructures, including those 8 basic infrastructures we defined, is at the bottom part. And the smart city platform is on top. And the sensing and data collection system is right in the middle between the SCP and the city infrastructure. So the sensing and the data collection system we defined as a system that monitors the status and collects the information of different kind of city infrastructures.
Dr. Chang?
Yeah.
Dr. Chang, this is Hyungjoo Kim speaking. Yes, sorry for interrupting you, but the slide doesn't move.
Doesn't move?
Yes.
Is it move now?
No.
Then I have to stop sharing and reshare again.
Please.
Okay. Is it showing now?
Yes, I can see your slide now.
Is it showing the relationship slide?
Yes, right.
Okay. Thank you, Dr. Kim. Right. Okay. Where we have seen the definition of this sensing device and data collection system. And as far as the relationship is concerned, this figure shows the relation between the SDCS and the Smart City platform, which is the SCP. Well, SCP, which defined in the Y.4201, has the actually has the ability to acquire data directly from different kind of sensing devices. However, with a large deployment of sensing device among all kind of city infrastructures, the SCP is unable to manage all the sensing devices. So the SDCS can both provide raw sensing data to the SCP and also work as an agent to control and acquire data from the sensing devices to SCP. And when the SCP acquires data directly from different kind of sensing devices, there is no need for the SDCS to process the sensing data. And the SDCS is working on a transparent transmission mode and transmitting data through acquisition B here to provide raw sensing data to the SCP. When there is a large deployment of a sensing device among city infrastructure, the SCP, well, can say maybe unable to manage all the sensing devices. So the SDCS will need to be used as an agent to control and acquire data for the SCP. And at this time, it is working on agent transmission mode and transmit data via acquisition interface A here. So it also uses unified data management and standardized open interface to provide support for different vertical applications, and it also in charge of the device control and linkage management for those city infrastructure sensing devices. Well, as we mentioned before, smart city platform is defined in the Y.4201, and the acquisition interface is defined in Y.4200, and the sensing and data collection system is defined in our ongoing work item Y.infra. Okay, does it change to the next slide?
Unfortunately not.
Okay. How about now?
I think, yes, we can see your slide. So we see your slide named the functionality.
Right?
Yes.
Okay, thank you. Thank you, Dr. Kim. So as we know that for the smart city scenario, usually it uses the SCP on top of the SDCS to interact between IoT device management provided by different industries or even different suppliers. The SCP is the, we can say, the application enabling platform whose main focus is the interaction with various industries and cross-industry platforms, rather than the direct interaction with sensors and control terminal equipments. And the Internet of Things applications of smart city runs on the smart city platform. Well, in the meantime, the SDCS is focusing on the direct interaction with sensors and control terminal equipments, and also supporting data sharing and exchanging between different vertical industries without SCP. In smart city, the sectors such as water, industrial, water management, or intelligent transportation, energy supply, all of these kind of sectors may have their own platform to manage and control the corresponding industries. But the most important thing for application enablers is to coordinate all these industries. So the application enabling platform, which runs on the SCP, will communicate with the SDCS and integrate the aggregated data information from those systems. And the application enabling platform can initiate operation command to the following SDCS, and then this system will start to correspond the command to operate corresponding end devices. So the SDCS can provide also can provide a safe and a reliable full linkage management of all kind of sensing devices using one field of the city infrastructure, and also support various applications of FCP. Actually, there are mainly four functions for the SDCS, which are the device control, the linkage management, the data collection, and the sensing and networking. The device control function, which offers mechanisms for the device identity or establishing equipment database of sensing device in the city infrastructures. They also can provide device operation, include authentication or authorization, or like a status report, fault detection, remote firmware updating, that kind of operation. And in order to realize those functions, the device control will need to provide a dynamic information database of the city infrastructure and completes the accurate identification of sensing devices, and also realize undistributed inventory and the loophole scanning coverage of the sensing equipment. And the second function is the data collection function. Well, it supports the collection and processing of sensing data. It also can receive data from sensing devices and enable the movement of a large amount of data. And the data processing and analysis functions to generate new data or modify the existing ones. And also they can, I think they can support data protections or data access control or information resource sharing, or this between different SDCS for different field in the city infrastructures. So they need to have the ability to storage, retrieval, and classification of all the information of sensors, and also controlling and configuration data. And for the data security concern, it could support the access control of sensing data, enabling the ability to control how this data are exposed to upper layer applications. And as for the linkage management function, I think it can provide connection between SDCS and SCP and support acquisition interface, which is defined in the WIDO 4200. And moreover, it supports interconnection between multiple SDCS of different field of city infrastructures. It also manages links for the sensors deployed in the city infrastructure. So basically, it supports both transparent and agent transmission, which we mentioned in previous slide of the sensing data between SDCS and SCP. And for the sensing and networking function, well, it's provide the ability of intelligent perception of the city infrastructure through a variety of information acquisition equipment like or the sensors or the surveillance cameras or GPS terminals. Also, they can provide available physical link for the sensors deployed in the city infrastructure. It seems that doesn't, okay, change. Right, so that's all for my presentation, and appreciate your time and attention. Thank you all. Back to you, Dr. Kim.
Okay, thank you so much, Dr. Chang, for your kind of presentation. And before having today's session, you mentioned that after your presentation, you have to read earlier. So is it right?
Yes,
Dr.
right.
Chang?
Yeah.
Okay, So people you're leaving, if you don't mind, I would like to check, are there any question in the Q&A chat box? So far, I haven't seen any question from the audience. So if you don't mind, on behalf of audience, I would like to give the short question to you before you're leaving. Is it okay for you?
Okay, sure.
Okay, thank you, Dr. Chang. If then, thank you for your kind presentation. So my question is that what is the key function of the sensing and data collection system? So
Well,
could you reply back to all of
yeah,
us? Thank you.
Okay, thank you, Dr. Kim. Well, I think as far as the key function of the sensing and data collection system is concerned, there are mainly three aspects: the sensing, the management, and also the interconnection. For the sensing means the using sensors to acquire the data from those city infrastructures. And this is the fundamental functions of the sensing and data collection system. And the management, well, is we can say is to manage the sensing devices, sensing data, and so on. And the interconnection, well, means the data exchange between multiple SDCS. I think those are the three key functions. Thank you.
Thank you so much, Dr. Chang. I have one more question to you. It seems that the SDCS has part of same function in the SCP. So what is the difference?
Right. So I think this is a good question. If you look at the WIDO 4201, the SCP has the functions to manage the sensors, or it can acquire data directly from sensors. These kind of functions are same as the SDCS. So that's why the SDCS has two working modes: the transparent mode and the agent mode. I think those combination could be used according to the deployment scenarios. Let's say if we it is a small scale of a city, the SCP could directly control the sensors, then we can use the SDCS in the transparent mode. If it is a large scale smart city, which we need to deploy the SCP and also the SDCS, then the SDCS is need to be working at the agent transmission mode, which control or the acquire the sensing data for the SCP. Thank you.
Okay, thank you. Thank you, Dr. Chang, for your kind answer. So with that, I have double check with the Q&A chat box. I see. So far, I have no question from the Q&A chat box. So okay, Dr. Chang, thank you so much for your kind presentation. Thank you.
Thank you, Dr. Kim.
Okay, thank you so much. With that, may I invite our last speaker to this session. The last speaker is Dr. Weining Du, Associate Researcher at the Wuhan University, and she's an editor of ITT Study Group 20. So she got her PhD degree majoring in photogrammetry and remote sensing from Wuhan University, Wuhan, China in 2017. And now she is the associate researcher on a state key laboratory of information engineering in the surveying, mapping, remote sensing, Wuhan University. And her research interests include a sensor web and integrated sensing for smart sustainable cities, especially for poor life cycle plot monitoring. So currently she acts as the contact between ITUT and Wuhan University, and she serves as the editor of multiple ITUT work items. So Dr. Du, the floor is yours.
Okay, thank you, Mr. Chairman. Could you see my screen and hear my voice?
Yes, I see your screen and I can hear your voice quite well. Thank you.
Okay, thank you, Mr. Chairman. Yeah, good afternoon, dear colleagues. I'm Dr. Wang Yingdu from Wuhan University, Wuhan, China. Today, my presentation is about Y.SMS, the draft recommendation for functional framework and requirements for disaster monitoring system. So first, I will introduce why we need disaster monitoring system, DMS. Okay, as we know, there are many sensors deployed in cities. But for a specific disaster, we only need a small group of sensors to achieve the monitoring of it. And also, just only one single sensor cannot complete the mission of disaster monitoring. So how to collaborate with multiple sensors is another problem. So a disaster monitoring system is created to resolve these two problems. First, how to efficiently discover the suitable sensors from the large amount of sensors deployed in cities. And the second is how to collaborate with multiple sensors to achieve the monitoring of disasters. Okay, the relationship between SCP defined in ITUT Y.4201 and sensing and infrastructure providers is defined in the right figure. Okay, disaster monitoring system is belonging to the sensing and infrastructure providers and interact with sensing and data collection system and SCP. So I will introduce some concept relationships in DMS. Firstly, in physical space, sensors have their unique sensing capabilities, and sensors can monitor disasters. And in the cyberspace, as in the disaster monitoring system, sensing capability representation is the digital representation of sensing capability, and disaster representation in DMS is the digital representation of disasters. Okay, after we understand the relationship between these 5 concepts, then we can see the workflow of disaster monitoring system. Disaster monitoring system interacts between SCP and sensors. Firstly, DMS collects capability information from sensors, such as sensor A, sensor B. They collect the sensing capability information from them, and DMS register these sensing capabilities information in its backend database. So when there are sensor list requests from SCP for disaster Y, then disaster monitoring system will extracts disaster monitoring demand, such as temporal demand and spatial range for the disaster Y. Then disaster monitoring system will register the disaster monitoring demand into its database. Then DMS will match between the request of disaster Y and the sensing capabilities of the sensors. Through the match, we can acquire the sensor list for SCP. Yeah, the sensor list in SCP, there can be sensor combination, or we can call it sensor group. Yeah, the sensors in it can be the functions of the sensor in it can be complementary and centenary and so on. So after SCP requires the sensor list from DMS, they can interact with specific sensors in the sensor list to acquire data and process data for further decision making. Okay, that's all the workflow of DMS. Okay, the main functions of DMS, they can be classified into 4 main functions. First is disaster representation management. Second is sensing capability representation management. And third is disaster collaborative sensing. And fourth is security. Yeah, for the disaster representation management, it's mainly used to manage disasters, disaster representations. It can add some items of disaster representations, new disaster representations, delete and update disaster representations. Yeah, the second function, sensing capability representation management. It can be used to manage sensing capabilities. The main function is add, new, delete, and update sensing capabilities. Third is disaster collaborative sensing. Is to produce a schema for collaborative sensing. Yeah, the sensors in the schema can be complementary, synergy, and enhancement. The fourth function is security. It's mainly for the authority for different users. Oh, that's all the functions of DMS. Okay, that's all for my presentation today. Thank you.
Okay, thank you so much, Dr. Du, for your kind presentation. With that, I have checked the Q&A box here. I see 2 questions. I'm not quite sure. Those 2 questions are who can responsible for this question. But anyway, I would like to read this question. So first question in chat box is what is going to be the role of drones in mapping the spatial dynamics of urban phenomena in microscale to support urban management in Africa? So that's one question. And the second question is that from John Goodart, for the presented architecture, is there a designated governance model in place that helps drive such a large long-term project? If so, can you name some major features of the approach model that have proven to be of high importance? So we have received 2 those questions. So among all the speakers, please kindly feedback from those two questions. Anyway, we have covered all the speakers' presentation, including Dr. Du. And from now on, we are going to have the Q&A session. So people, I believe each speaker, they may need to have some time to feedback on those two questions. So in this regards, firstly, I would like to ask the relevant question to each of the speaker. So first question to Junsup. What is definition of smart city platform, and what is main difference with a city platform? So can you simply feedback on my request, on my question? Thank you, Dr. Junsup Lee.
Thank you, Dr. Kim. Yeah, I think you all the audience already heard the definition of smart city platform, which is defined in ITU-T Y.42.1. There's a request for the video from the host. Sorry for that. Okay. As we already heard from Jishin Sang, Dr. Jishin Sang, the presenter on the Y.42.1 and 4200. So smart city platform is defined in Y.42.1 and is defined as a city platform that offers direct integration of city platforms and the system, or through the open interface between the city platforms and third parties. So smart city platform can, is defined like this, and main difference with the normal platform in the city, just another system in the city, is the integration and interconnection of system in multiple silos. So basically, city platform or city system is dedicated for the specific silos, specific the verticals, but the smart city platform we're trying to define in ITU is system which can interconnect and integrate vertical silo system and provide value-added services to the city by integrating or through the open interface. That's the main difference with the normal system in the city. That's all. Thank you.
Okay, thank you so much, Junsup. And the next question is directly go to the Dr. Jishin Sang. Thank you, Dr. Jishin Sang, for your presentation. What is the next for the series of standards?
Thank you, Dr. Kim. I think that the series of recommendations on smart city platform can be developed. Maybe we can have new work items. We can give a detailed description of the functionality defined in Y.4201. So I think we can have more standard for this series, and we can give a data model or data processing and for the decision making on a smart city platform. So that is our suggestion for the future and for the new work items in SG20. And we also can have a new work item for the related part, that is for the application and the service part. And we have described in the diagram, and maybe we can have new work item related to computation and data processing that connected in eastbound or to SCP. So that is our suggestion for the new work item for this series of recommendations. Thank you, Dr. Kim.
Okay, thank you so much, Dr. Zhishen Sang. And when you take a look at the Q&A box, I see a question from Mr. Jan Guda. I think the Dr. Zhishen Sang, you are most appropriate experts to explain, to give feedback to the question by Jan Guda. So, Dr. Zhishen Sang, please.
Yeah, thank you, Dr. Kim. And also thanks for the questions from Jen. Good at. You know that for the smart cities, currently we are defining technical part of smart city from the aspects of IoT and ICT. And generally, smart city is not only for the technical issue, it is also related to governance, related to financial issues for the master plan, and for the stakeholders for the that is work related not only to technical issue, it's also related to the management and maintenance. And we have developed some of the technical reports in the focus group, and also developing in SG20 that is a supplement to this Y.4000 recommendations. And so you can say that we have given some of the solutions related to governance and to the long-term financing and issue and for policies and maintenance of operation and maintenance of smart cities. And so we can say that is also related to the work of smart city. And I hope that I answered your question. Thank you.
Okay, thank you, Dr. Zhishen, for the feedback. I have another question.
Yeah.
Sorry, Zhishen?
Yes, I read from the chat books. That is, there's another question. And with your permission, Dr. Kim, I would like to answer this question. That is,
yes, please go ahead. Yes, please.
How China is building ecosystem for expert capability for smart city. Yes, and you know that in China we have more than 10 years working on smart cities, and in the national level, in the city level, we have expert group and to give suggestions for the master plan and for the financials, for the policies, and also as well as have the technical issue for how to build smart sensible city. And that is, I think that is the ecosystem. And we also try to identify the stakeholders related to the smart city. And that is related to the organizations, related to the regulators. And we also try to find the companies working on hardware and working on software and working on platform and also applications. And in the government side, they have built a specific bureau of smart cities. And in some of the city, they call it Bureau of Big Data. And in some of the city, is called the Bureau of Building Smart Cities. And that office is coordinating the work of smart city. And they have tried to combine in development, especially, I think the first step is to develop the infrastructure. Then they provide the service for all the citizens. That is the work. And it has been carried out for more than 10 years. And they also have some of the experience, and we try to think out the technical issue, and we try to make it as a standard, and national standard and the international standard. So that is what we have done, and I hope that I have answered your question. Thank you.
Okay, thank you so much, Dr. Zhishen. So with that, my next question is directly goes to the Dr. Du. Dr. Du, thank you again for your kind presentation. I have just one the fundamental question. Why do we need disaster monitoring system in smart cities? And what function should disaster monitoring system have? Thank you.
Okay, thank you, Mr. Kim. Yeah, I will make some explanation about your question. Why we need disaster monitoring system? Okay, as I stated before, yeah, there are many sensors deployed in cities. Yeah, maybe tens of thousands of sensors deployed in cities. But for a specific disaster, maybe just like the flood in Zhengzhou, China this summer. Yeah, for this disaster, we only need, not all the sensors deployed in cities can be used in this disaster monitoring, as just like a satellite sensors. You know, satellite sensors, they have different spatial range at different time, just like MODIS. Maybe in China, there are, as I know, there are only two time instance MODIS will monitor China. It's in, if I might remember it right, it's on the 9:30 p.m. and 16:30 p.m. Yeah, there are only two time instances the MODIS will fly over China, and that means only at these two time instance, MODIS will have data about China, the spatial ranges of China. So what we need to do, we need to select sensors from the large amount of sensors in cities to complete the monitoring of disasters. Also, just one single sensor, just like if we want to monitoring the flood in a basin, yeah, we need many sensors, just like in the upper and lower of the basin. Yeah, many hydrological stations, many water level sensors, precipitation sensors to collaboratively to perform in the monitoring of disaster. So the disaster monitoring system is created to resolve two problems. First, how to select sensors from the large amount of sensors. And the second is how to collaborate with sensors to achieve the monitoring of disasters. Yeah, that's why we need a disaster monitoring system. And that's my response to your first question. So as for the second question, yes, what's the main function of disaster monitoring system? Yeah, in my opinion, there should be four main functions. Yeah, I think we can see my slide.
Okay.
Okay. Yeah, can you see my slide?
Yes, yes, I can see your slide. Please go ahead.
Okay. I think there are mainly these 4 functions of DMS. First, disaster representation management. It is the disaster representation management is to, map the disaster in physical world to DMS. We cannot directly manage disaster in DMS, but we use representation of disasters. That is disaster representation. Just like we use structured document to represent the time, location, the theme of the disaster. So SCP, the SCP can know where and when the disaster occurred. So that is to represent the disaster. The second is sensing capability representation management. The function is to map sensor and sensing capabilities into the cyberspace. Just like we know there are many sensors deployed in cities, and these sensors, they have different sensing capabilities. So we use this function to let SCP know we have how many sensors and which sensors we know, and what's the main capabilities of sensors. After we know where the sensors are located and what's the capabilities of sensors, so we can discover suitable sensors for specific disaster. That's the disaster representation management and the sensing capability representation management. These 2 functions are the basis for the disaster collaborative sensing. Disaster collaborative sensing into do the mapping between the disaster representations and sensing capabilities. Just like different disasters have different sensing requirements. Just like for example, just for the flood in this July in Zhengzhou, China. We need the sensors which can monitor, which have data in July this year, and the location should be Zhengzhou, China. That's the requirement, sensing requirements from disasters. And also, if we request, so we need to, do the check in the sensing capability database. Just like we need to know which sensors have data in this July, and its spatial ranges is in Zhengzhou, China in this July. Through the mapping, the disaster capability collaborative sensing can find the sensors to monitoring the specific disasters. And for the security, it's for the different authority for different users. That's all my response to your questions. But I'm not sure if I'm clear if my answers are clear to your questions. Thank you.
Thank you so much, Dr. Du, for your precise the response. I believe the feedback, your response are quite good enough for the question, I hope. With that, I see additional question in the chat box from Dr. Sani Paye. I'm not quite sure who's most appropriate experts to feedback on this question, but I will repeat this additional question in chat box. What do you think about the real link between digital transformation, for example, smart city, and sustainable development? What are the real impacts of digital transformation on ecological, for example, energy, transition, and socio-economical inequalities? So that's the question from Dr. Sani Paye. So who gonna answer for this question? Dr. Jishin or Junseok?
Dr. Kim, I would like to give some points.
Okay, please, Dr. Jishin.
Yes. And you know that in ITUT, we define the smart city as smart sustainable city. And that means we are not only address the issue related to the ICT part, we also address the issue of sustainability. And generally, we think that ICT can play an important role in solve the problem in smart city. And so that is what we are doing the work of standardization. And for the sustainability issue, we think that is also related to other issues related to the policies and related issue what have been defined in UN SDG issue. And we have make the aim from eliminate poverty, and we have the aim related to the environmental sustainability, related to biodiversity, related to the oceans and the living paths. And we think that in this regard, that ICT, especially for the digital transformation, can play also an important view. For example, if you have transferred the traditional service and applications from a regional part to the digital part, and you can improve the efficiency, and you can know who needs this kind of service and application, and you can provide better service, and you can provide good service, and we think that is in some sense is related to the sustainability of the world, of the city. And in SD20 and ITU, we are working in digital transformation methodologies, and we in ITU's perspective, we also try to improve SDGs of the UN SDGs. I think that is what we have done in the city level. That is a smart sustainable city. Thank you, Dr. Kim.
Okay, thank you, Dr. Jason Zhang, for your the answer. So we are almost approaching on the closing time of the session. I see no more question at Q&A box and as well as the chat box. So before a closure of today's webinar session, I would like to kindly invite the Tanya, the Vice Chair of ITUT Study Group 20, for her kind closing remark. So Tanya, please, you have the floor.
Thank you very much, Dr. Kim, for the excellent moderation. And also big thanks to all of our speakers for joining us today. Personally, it has been a pleasure to be able to contribute to the organization of this webinar together with ITU, CICT, and ETRI. As we have learned today, standards are key to provide the necessary technical guidance for implementing different types of smart city platforms and help cities achieve the sustainable development goals. I work at UNI, that is Spain's only standardization organization designated by the Spanish Ministry of Economy, Industry and Competitiveness to the European Commission. Standards provide the knowledge, consensus, and collaboration that this global challenge requires, establishing a common language and measurable criteria. Standards reflect the best practices in key aspects for the competitiveness of organizations, providing an effective response to the major challenges facing cities, companies, and also public administrations. We have been delighted to contribute actively to ITUT Study Group 20 since its inception. As a vice chairman of ITUT SG20, I can assure that we will continue to work with ITU's diverse membership to develop standards that help cities and related stakeholders to meet the technical requirements of IoT systems and smart city platforms. We expect to publish the draft recommendations that were mentioned today very soon. Please look forward to that. I encourage you to join us in the rest of ITU webinar series on digital transformation for cities and communities and learn more about ITU standards. I would like also to encourage you to join the work of the United for Smart Sustainable Cities initiative, the USSC initiative, that is also developing best practices on the smart cities platforms. If you have any questions or feedback regarding the webinar or the work of ITU on smart sustainable cities, please feel free to reach out to us. Please also be informed that the highlights of this webinar, including key recommendations, along with all presentations delivered, will be made available on the ITU website, where you can also find our contact information. Allow me to conclude by thanking the excellent ITU team for their great support in the organization of this webinar, and all of you for your participation. I wish you a wonderful rest of your day. Thank you very much.
Thank you so much, Tanya, for your kind closing remark. Thank you. Thank you so much. So with that, I would like to the closure of today's webinar session. Before closure of the session, I really wish you are healthy, and I really hope to see you all via offline sooner or later. Okay, with that, this is the closure of the session. Thank you so much. Bye-bye.
Thank you, Ms. Marcus. Thank you to our panelists, and of course, thank you, Dr. Kim, and to all our co-organizers. Of course, thank you as well to the participants for attending today's episode. Please do note that the next episode of our webinar series will take place tomorrow, so you will see it on the screen. Episode 7 is on crowdsourced systems, a people-led paradigm. So kindly note that the registration link is the same for all our episodes, so you don't have to re-register. So you just have to save the date and of course the connection details. And if you want to check out the other episodes, I think my colleague already shared it via the chat box. So please do check the link. So once again, thank you, and and enjoy the rest of your day. Thank you. Bye.
Thank you. Bye-bye. Thank you, Chira. Thank you,
Thank you.
Gypti. Thank you, TSB Secretariats. Bye-bye.
Thank you. Bye.
you